Okay, hi guys. In this video, what we're going to be doing is exponential functions. So, um, the first thing that I want to introduce you with this is that there's a difference between exponential and linear functions, okay? Exponential functions are a type of function in algebra. Now, there is one such function that we do in algebra that basically you would kind of, it's basically what you would do it in algebra. You work with them in algebra, and there can be a functions of the form y equals a to the x where a does not equal 0. So we can have y equals 2 to the x, y equals 3 to the x. One of the things that I do want to emphasize for this is the form of an exponential function. So we have y equals e to the x minus h plus k, okay? Now, I'm sure you all have heard of e to the x. Maybe you've heard of it, or you've you've kind of know how it looks. Basically, e to the x is a function that we're all, you may or may not be familiar with it, but in algebra, a lot of people work with these kind of functions, especially when you go to higher level math like calculus. This is the exponential function. And notice that it's exponential because it's exponential growth, okay? Now, there is, another kind of function where we have y equals a to the x minus h plus k, and where a does not equal 0. But that's a little more different. You can always, also you can always have something in front of your e, so you can have y equals a e to the x minus h plus k if you wanted to. I don't really see those as common as the functions like y equals 2 to the x. But that's kind of the notation. So the other thing is that when you do 1 to the x, that's a constant function. That doesn't really count as an exponential. At least I don't think it does. It's just y equal to 1, basically. So I don't really think that would count as an exponential. However, for other ones, yeah, like if you have y equals 2 to the x minus 1 plus 3, that does count. So if we go ahead and just graph the exponential function, we can do it, as best as we can, is what I'm trying to say. So if we get a line here, so we're gonna do 2 lines, and I'm gonna pause meanwhile I make this graph. Okay, so I just made this really small graph. If we do y equals e to the x, so if we do, or we can say f of x equals e to the x, what you're gonna do, you're gonna try your best to plot points. So if we make a table, so if we kind of do something like this, where we if we make a table really quick, okay, and if we go ahead and just, so we're gonna plug in numbers, okay? We're just gonna say y equals, and you can do this on Desmos if you want. So give me 1 second. Okay, so we're gonna go ahead and use our graphing calculator, not to graph it, but just to plug in numbers. So e to the negative 7, for example. So if we do e to the negative 7, it's about 0.0009, so it's very, very close to 0, as you can see. We're just gonna put it right here, okay? And then we have e to the negative 6, so basically you just want to kind of, you know, plot it as best as you can. E to the negative 6, 0.002, so we have 0.002. We're going to go ahead and plot that so we have a little bit closer. And it does not have to be perfect, you know, because I know these are kind of tough to graph. E to the negative 5, 0.0067, so about, you know, just a little bit closer. As you can see, we can just do this because it's going to get closer and closer to 1. Remember, e to the 0, anything to the 0 power is 1, okay? You're going to go e to the first power, so e to the first power, e is approximately 2.71. Also, what I wanted to mention, e originated from the number e, by the way, that is a number. It is Euler's number. So basically, it is called the Euler number. So it's very important to know that. They won't ask you where it's from, but you know, it's a good thing to know. Because it just tells you who created it. I forgot the full name of who it was that created it, but his last name was Euler. That's why, you know, he kind of discovered it. And so it is approximately 2.71. You know, for the number, that's what it approximately equals. And so if we go over here, we can see that it, honestly, as we go higher and higher and higher, it's gonna get, at first you don't really see it growing, but then as you go further and further in your x, you see that it grows a ton, and it grows exponentially, okay? So that is kind of how e to the x looks, and let me just verify that that's how it looks, because yes, so you see how it kind of goes like this, and then you go up and up and up and up, and it kind of goes at a very high rate versus a linear function, which goes at a very constant rate, okay? If I set x plus 1, for example, you know, they both touch 0, 1 here, but they don't, I mean, they wouldn't really, this one is going, like, for example, when x equals 3, or actually when x equals 3, y equals 3, right? Well, when x equals 3, if we go all the way to 3, here on the x-axis, if we go all the way to 3, it's going to be about 20.086. So 20.1 or 20, if you want to put it that way. But you see how that is a lot higher than what we got for our x, which was a 3. Or for our x, we got a 4, actually, for x plus 1. So you see, even though they touch the y-axis, excuse me, they, you can see clearly that they both have, basically the exponential function is growing a lot quicker than the linear function, okay? Also, this is not a constant rate of change. A constant rate of change is always linear. So the rate of change for this is not really linear. It is exponential. Actually, it's not even, I don't even think that the rate of change, it's not constant is what I'm trying to say. So that's why for this, you would get something like this. And that's what an exponential function is. Now, as far as graphing exponential functions, there is a rule that, so for example, if we have, so for example, the transformations of functions, e to the negative x, for example, if we look at e to the negative x, you can see that it is a reflection in the y-axis. It's just like whenever we had x and we would reflect it across the y-axis, we had negative x, right? It's the same with this. E to the negative x is just a reflection across the y-axis, okay? Now there is a number that you would do that, or a function that you would do where it's of the form y equals a to the x. Now, basically how this works is if it is greater than 0, yeah, if it's greater than 0, or actually greater than 1, it's going to be an exponential growth, okay? If it is less than 1 or less than 0, actually, it's going to be exponential decay, okay? If we, so for example, if we have y equals negative, if we have it raised to the x, or actually, no, my bad. So what I'm trying to say is if it is, so let's see here. So I want to make a little correction to this, actually. So in reality, this is y equals a b to the x, okay? So when we have something like that, that means that, for example, if b is less than 1, it's going to look like this, okay? If b is greater than 1, it's going to look like this, okay? And so basically, if we have, for example, e to the x, that's 1 times e to the x. And so, because e is greater than 1, it is exponential growth, just like it is right here. So, and then if it is, for example, reflected across the y-axis, in reality, so if it's reflected across the y-axis, it is f of negative x, so it's y equals e to the negative x. So y equals e to the negative x would look like this. Okay. So it's really important to know the differences between these two before you actually start doing equations and stuff. So we're gonna go ahead now and try to graph functions that look, that are, and we're gonna start off very simple. We're not really gonna do like too much. So if we kind of do a graph here, and okay, so let's just say we want to know how to graph 2 to the x. The best way that I would do this, if I were you guys, like the best way that I would do this is by making a table of values. So when x equals, so for example, I can say when x equals -4, or actually, I'll say it's all the way up to 3 for this one, because apparently yeah, so I'm gonna just say it's up to 3, because the thing is, if it's up to 4, it's gonna be a lot like more. So yeah, so the thing is, so basically we're gonna just do up to 3. Now so basically the way that I would do this, I would just start plotting, start plugging in table values. I'm gonna go -3, -2, -1, 0, 1, 2, and 3. Okay, and what I'm gonna do is when I say f of x, so I'm gonna turn this into f of x. F of x equals 2 to the x. So that means that f of -3, sorry guys, that was an airplane. Okay, so when I say f of -3, that's 2 to the -3 power, which is 1 over 2 cubed. That's 1/8. So if I go an eighth of 1 here, so basically when I have -3, I'm gonna go an eighth of 1. I'll have, so basically 1, 2, 3, 4, 5, 6, 7, 8. So it's gonna be about right here. Okay. Now if I go, so if I do, so it basically this is 1/8, right? F of -2, that would be 2 to the -2 power, which is 1 over 2 squared, which is 1/4, okay? So this is 1/4. Now, it's going to be a fourth of 1, basically. So maybe about right here. And then if I go -1, so if I plug in -1, f of -1 will be 2 to the -1, which is 1 over 2 to the first power, which is 1/2. Okay, so this is going to be about halfway, about half of 1, which is 0.5. Okay, and 2 to the 0, of course, 2 to the 0, that's 1. So f of 0 is 2 to the 0, which is 1. So we have it right here. And then we have f of 1, that's 2 to the first power, which is 2. So we have, oops. So when x equals 1, y equals 2. And then f of 2, that's 2 squared, which is 4. So it's going to be 4 up here. And then when x equals 3, f of 3, and I can just go ahead and erase these out. So f of 3, for example, and this is 1, this would be 1/2, this would be 2, this would be 4, and then f of 3, I would say 2 to the third power, which is 8, okay? So there's one very important thing to notice about this table of values, okay? when you have, so basically to get from here to here, you multiply times 2. To get from here to here, you multiply times 2. To get from here to here, you multiply times 2. To get from here to here, you multiply times 2. Get from here to here, you multiply times 2. And to get from here to here, you multiply times 2. Now, notice how we have y equals 2 to the x. That means that basically we have y equals ab to the x. And so we would say something along the lines of, so let's see. If I actually do y equals a to the x, or ab to the x, I can say here that if we have, for example, if we have something like a for 1, or 1 for a, for example, so if I make a equals to 1, right, and then I go ahead and do b equals to 2, I can get my function, which is, so basically a equals 1, b equals 2. So I can say that this is the same as saying y equals 1 times 2 to the x power. Now there are other functions where they give you y equals 3 times 4.5 to the x. You have to just pay attention to how it looks. The best way, though, that I would graph these is by table of values. That will be the best way to do it if you are really, really stuck on how to actually do it. So this would be our function here. And of course, there are translations and stuff. So basically, let's just say we have y equals e to the x minus 1 plus 2. This is almost the exact same thing that we were doing with quadratics and polynomial. Like basically when you stretch, or when you shift functions, okay? This one is just saying it's basically a transformation basically saying that you have, it's going to be 1 unit right and 2 units up. So for example, if we have the function y equals e to the x, which we graphed up here, we would just say, well, it's just 1 unit right and 2 units up. 1 unit right and 2 units up. So basically, like, you would go ahead and do a, basically kind of like a shift of all the points on the function. Let's just say that, you know, in kind of shifting gears a little bit, if I had a function that looked something, so basically a function where we have a point here, a point here, and let's just say point here, a point here, and a point here. So let's just say that we had this kind of, it's not really a linear function, it's a piecewise, but you don't learn those until like a really, you know, you don't learn those until Cal 2, I believe. But you don't have to think about those right now, but I just really want to show you guys what I mean by actually shifting functions and stuff like that, because The thing is that I feel like a lot of students get confused on this. When I say that, so for example, if I say that this is f of x, right? This function here, we have f of x, and it's a piecewise function, right? Then I say, what is f of x plus 2 minus 3? If let's say this is negative 3. This part is, how much is it? It would be 1, so 1, 2. This is 2. So let's say this is negative 3 comma 2, and I'm going about 3 units down and 2 units to the left, okay? So this is my function here, right? And I'm gonna go 3 units or 2 units left. So basically, when you have this, that means that you're going left 2, not right, but left. Remember that when you have an addition in front of your x plus h or x minus h, that means it's gonna go to the left. Always think opposite when it comes to like parentheses and addition, okay? So this is going to go left 2 units, 1, 2. So if I color code, it's going to go 1, 2, right? And then we go down 3 units, 1, 2, 3, okay? That's going to be my new point. If I do this one, okay, so if I do this one, it's just going to go, it's going to go 2 units left and 3 units down. So 1, 2, 1, 2, 3. This is going to be my new point. So that's what I mean by shifting functions. I don't want to go too much into this because this is not what the video is about. But let's just finish this problem up. If I have this function here, e to the x, that I graphed it all the way over here, I'm going to go 1 unit right. So 1 unit right, because remember, it's minus, so that means that we're going to shift 1 unit right and 2 units up. So we're going to have something like this. So we have, or let's do 2 to the x, since we already have it graphed. We're going to go 1 unit right and 2 units up, okay? So we have, we're going to try to do y equals 2 to the x minus 1 plus 2, okay? So 1 unit right, so we have 1, and then go up 2. 1, 2. We're going to do the same for this point. For this point here. And you don't have to do it exactly, but you can. So it's 1 unit right and 2 units up. It'll be something like this. Now, if you don't like to do that, if you really don't like to do that, you can just do a table of values, okay? Because I know that it's kind of frustrating and it's confusing. So, for example, if we have, let's just do f of, for example, f of 1, we would have 2 to the 2, or 2 to the 1 minus 1, right? Plus 2. This would be 2 to the 0 plus 2, which is 1 plus 2, which is 3. So when we plug in 1, we're going to get 3 out of it. Oh, and then, yeah. And then, you know, that's how it would be. And basically, so that's kind of how it would be for that. And then you would go ahead and do the same thing for 2 squared. So you would say f of 2 would be 2 to the 2 minus 1, which is, and then plus 2, and then you would say 2 to the 1 plus 2. That's just 2 plus 2, which is 4. So you would go ahead and and for 2 you would say 4, right? And then for 3, I mean, you can do for 3, but it would probably go off the, or actually no, it wouldn't. If you do f of 3, you can say 2 to the 3 minus 1 plus 2, which is 2 squared plus 2, which is 4 plus 2, which is 6. So you're going to have the 0.36. And then if you do 0, you would get 2 to the 0 minus 1 plus 2, which is, really it's 1/2 plus 2, which is, I believe it's 2.5, if I'm correct. So we would have something like this. And then if you do -1, 2 to the -1 minus 1 plus 2, this would be 1/4 plus 2, which is 1 times 1 plus 2 times 4 over 4, which is 1 plus 8 over 4, which is 9 over 4. You can simplify that as a decimal. If you do, so if you simplify it as a decimal, for example, 9 over 4, that's about 2.25. So it would probably go like over here. And then you would just go like this. As far as asymptotes and like horizontal asymptotes, and because that, I mean, I don't want to push you guys to know that yet. That just means that there is a line that the graph kind of goes to but never touches. But that is a whole, that is another concept. That's like going into kind of calculus or pre-calculus if you think about it. So I don't want to push you guys to know that just yet. If you do want to know what vertical and horizontal asymptotes are, so I can go over that once I do know rational functions, or once I go over them. But yeah, that's kind of the basics of graphing for this video. I know I went really quick, so if anybody has any questions, please let me know right away. But yeah, that'll be it for this video. And so in the next video, what I'm going to be doing is I am going to be actually getting into equations, specifically exponential equations. And I'm also going to introduce, just knowing how to do, because I believe I did do laws of exponents, but I'm going to do a review of that. And also, I am going to just do exponential equations, and then we're going to move on to logarithms and all that other fun stuff. So I hope this helps, guys, and I will see you guys in the next video. Bye, guys.